All right, welcome. Today we are diving deep into the massive security risks of these new agentic AI tools, like OpenClaw. But this isn't just about one shiny new tool. Nope. This is about a much, much bigger challenge. How in the world do we secure modern software when everything is so temporary?
And to kick things off, just listen to this warning. This isn't some critic or a competitor. This quote comes directly from one of OpenClaw's own maintainers. It really just perfectly sets the stage for the high-stakes conversation we are about to have.
So, let's get right into it. What exactly is OpenClaw? And, why did it seem to become an overnight sensation with developers?
Okay, so OpenClaw is not your average chatbot. Not even close. It's designed to actually do things. It plugs directly into your machine, giving it the power to run commands, read and write your files, even control your apps. And it gets crazier. Through a community hub, it can download and learn new skills for pretty much anything, from generating leads to setting up entire websites.
This incredible power is exactly what makes it so tempting, right? But as we're about to see, it is also what makes it unbelievably dangerous. And you can bet the cybersecurity community had something to say about this. Their reaction was, swift and brutal. Researchers didn't pull any punches, calling OpenClaw's whole architecture an absolute nightmare from a security perspective.
So why such a strong reaction? Why a nightmare? Let's break down the actual evidence behind these massive warnings.
Okay, check this out. A security audit of ClawHub, which is OpenClaw's community marketplace for those skills, found 341 intentionally malicious skills. And we're not talking about buggy code here. No, these were designed specifically to deliver malware, steal your credentials, and punch backdoors right into your system.
And this table, it just lays out the ugly truth. Researchers quickly found critical vulnerabilities, including one that allowed a complete system takeover with just a single click on a bad link. Think about that. That's not a minor bug. That is a fundamental architectural failure.
And here's the kicker. These aren't just isolated incidents. It's a pattern. You've got prompt injection attacks that can trick the AI, thousands of users accidentally exposing their agents to the public internet, and it all boils down to a design that basically treats security as an optional extra.
Which brings us to the million-dollar question, doesn't it? After seeing all this, does it make any sense to use tools like PenClaw, which uses OpenClaw to automate cybersecurity testing on your own systems?
On one hand, the promise is huge, right? 50% faster testing cycles, 40% more coverage. But on the other hand, you are handing the keys to your entire kingdom to an agent built on a platform with a documented history of critical flaws. It's a massive gamble. Are you willing to make that bet?
But hang on a second. The problems we're seeing with OpenClaw, they're not unique. In fact, they're a perfect preview of a much larger trend happening in software development. Let's just take a step back and look at the bigger picture for a moment.
The real story here isn't just about one risky AI tool. It's about this whole new world of ephemeral software, where our infrastructure is temporary, dynamic, and constantly changing.
We're talking about ephemeral environments. You can think of them as instant software or pop-up infrastructure. They get spun up on demand for one specific task, like a code test or an AI job, and then poof, they're torn down moments later. This is incredibly fast and efficient, but it completely shatters traditional security models.
So instead of thinking about one big static program, picture today's applications as a constantly shifting ecosystem of containers, microservices, and serverless functions. They are literally designed to be temporary and disposable.
And this is where we see the exact same problems that plague OpenCloud. You get configuration drift, where these temporary setups don't match security standards. Secrets and credentials get leaked in short-lived code. And your traditional security tools? They have massive visibility gaps because they can't see threats and workloads that might only exist for a few seconds.
So how do we secure a world filled with autonomous agents and instant software? Well, the old playbook is useless. We need a new one. The new strategy is all about building security in from the very start. So instead of trying to build static walls around everything, we need to embed automated guardrails directly into the process. This means using code to define what secure looks like, giving every user and system the absolute minimum access they need, protecting apps while they're actually running, and having one central way to manage it all.
Here is the absolute bottom line. You just can't rely on security checks before deployment when a workload might only exist for a few minutes or even a few seconds. Security has to happen in real time while the code is running, period.
And this is where technology like eBPF becomes a total game changer.
It works deep inside the Linux kernel, which basically gives it superpowers, a real-time view of every single thing happening on the system. This means we can actually spot threats in these ephemeral environments as they happen, without slowing our applications down to a crawl.
Ultimately, where this all leads is a zero-trust model. We have to start with the assumption that threats can come from anywhere, inside or out. This means your identity is the new firewall, and every single action has to be verified every single time.
By baking these principles directly into our development lifecycle, we can finally have both the speed that developers desperately need and the rock-solid security that businesses require. It's a totally different mindset. It's about building resilience in, not just bolting security on afterwards.
And that's the final thought I really want to leave you with. This new era of autonomous, ephemeral technology, it's not on the horizon. It's here, right now. The only real question left is whether our approach to securing it can evolve just as fast.